I'm a data engineer who builds cool stuff, end-to-end platforms, and today I am here to present about some cute things. So these are cute, but actually very helpful if you are into real-time streaming or dealing with OLAP databases and dealing with terabyte to petabyte scale of data. Let's start. So DuckDB and Smallpond. I'll start first with DuckDB, then we'll go for what is Smallpond. DuckDB is a SQL OLAP based database management system, and let's say if you are going for any database, you have to set up database first, then have compute, separate the storage and everything. DuckDB just packs everything in one, and it's an in-process OLAP database. Let's see where it stands in our database universe. So we for OLAP and client server, we have Snowflake, BigQuery, Redshift, and various other databases. But DuckDB smartly went for the empty quadrant that wasn't filled yet, and that is in-process OLAP systems. For transactions, we had SQLite since years, but analytical part was missing, and where DuckDB came and saved the day. So the best part is DuckDB has no external dependencies, just pip install DuckDB ready to use. You can use in web browser, you can use, there's a UI connected to DuckDB that you can use. It's like ready to there, you just SQL friendly, Python friendly, query your database as soon as you want. And there are no dependencies, everything is packed inside, pip install DuckDB, that's all you need. Alright, so let's have some comparison. First we'll go for 10 GB benchmark, 10 GB dataset. It was a CSV dataset, and there was DuckDB Polars. Polars mod is nothing but because Polars has some dependency issues, as it cannot. Polars uses Rust in the backend, and it loads entire data in the memory and runs out of memory. So we had to first load the data using DuckDB, and then processing was done using Polars. So this is the benchmark. If you see, when we increase the cores, DuckDB actually wins for 10 GB dataset. It's better than our OG PySpark. But when it comes to 100 GB, DuckDB is not that efficient because Spark has a distributed way of dealing with huge scale of data. Let's go for next. Now Smallpond enters the chat. So here if you see, DuckDB was not able to enter 100 plus GB of data, but it's nothing when Smallpond is used. And Smallpond is like a lightweight data processing framework developed by DeepSeek, and they open sourced it like a couple of weeks ago. They under the hood use Ray distributed mechanism and along with DuckDB. I'll explain. So Smallpond consists of a Firefly system, that is 3FS. Firefly file system. It's something where you don't need to have a execution level and then the physical level, logical level. All those are not required. Firefly system already deals with the partitioning and everything. It's fast. It is like connected networks of SSDs and RDMAs. So this Smallpond extends the efficiency of DuckDB to SQL analytics to the distributed environments, because DuckDB is only made for single node, but Smallpond solves that issue by using partitioning and multiple workers, multiple executors, and each executor is a DuckDB node like that. Smallpond has a Python API, like very easy to use one. And under the hood, it leverages Ray parallel processing distributed nodes. Let's go for other one. So we on the rightmost part is, as you see, that's Apache Spark. How Apache Spark used to work. First, it constructs the DAG. It has the query optimizer. Query optimizer basically figures out in what order to execute joins, mapping, aggregations, etc. And then it executes the plan, gives it to the scheduler, and then it goes to nodes for execution. Workers execute the data. And the Daft is something little over the Apache Spark, where it again uses the lazy execution DAG method, but first it optimizes for, first it has the logical execution plan, then it converts to physical, then it goes to workers and partitions and goes for execution. Now Smallpond smartly leveraged one task here, that it's distributed system, but using DuckDB nodes. So as you see, first it's also lazy execution tag, but partitioning is done manually. In both of them, partitioning is automatic on the basis of rows, hash, or even different ways of partitioning. But here the partitioning is done manually, and then each of the partitions are sent to the individual nodes, and individual nodes are DuckDB instances that are actually very fast in processing the data. Some benchmarking has been done using Smallpond by DeepSeek. That is like 100 plus terabytes of data has been processed in 30 minutes on the gray sort benchmark, and just like the fastest it has been able to process 100 plus terabytes of data. Let's go next. So this is some case study. This is actually, if for few, I think most of the people don't know, this is my second time presenting here, and first time I presented my project BetFlow. BetFlow is a platform that analyzes sports and betting data, real time and batch, both Lambda architecture. So here I'll show some case study. So if you see the pipeline on the left, that uses APIs, Kafka, Spark Streaming, and Druid. So we have Spark Streaming and Druid handling the real-time processing transformation part, and database, real-time database as Druid then goes to Grafana. But if you replace that entire streaming and Druid part with DuckDB, that uses, because DuckDB is OLAP, it's not made for streaming use case, but you can use Aeroflight under the hood. This is something that was recently released by Apache Aero and need another like 30 minutes for me to explain, so I'm skipping that. So if you replace Spark Streaming with that, you see the cost comes down to just like 67% reduction. That's the $213 per month I am gonna save if I am running my real-time pipeline every month. Because I don't have to have a heavy distributed clusters for Spark Streaming and Druid, and I'm going to save a lot if I just use DuckDB, because DuckDB is a single node and is very efficient. Second is the batch pipeline. So this pipeline I used to backfill the data of past 3 years of sports, like 4 games, NBA, NFL, and other NHL, and the betting data of all those 4 sports. So my old pipeline was just use Glue for everything. Now Glue has a backdrop that it uses couple of DPUs, data processing units, and after using data processing units, it just saves the data. So entire process takes $1,100 if I want to backfill 3 years worth of data, and $1,100 is a lot. That is like estimated. I am not calculating a lot of hidden costs here and how many times APIs hit again and again. But if you replace, if I replace the Glue part with DuckDB part, where I don't have to have Glue, because DuckDB can run anywhere, pip install DuckDB, cannot be easier than that. And you just have to use Lambda for that. I can have multiple parallel concurrent DuckDB and Lambdas running that are backfilling concurrently, and I would backfill at such a cheaper cost at $50, saving $1,100. That's like 95%. So these are some proposed calculations, not been tested yet, but I'm betting on it. All right. So if you want to connect, feel free to send me a request on LinkedIn.
Cool. That was super fun. And for I guess 2 things. One,